All right, looks like we are live. So anyway, welcome on in. Tonight's going to be a bit of a different stream. So I've told a few people about this, that I've been doing some disassembly work on a couple of games, NES games that is, on Gimmick as well as the original Teenage Mutant Ninja Turtle game. And tonight's focus is going to be on the Ninja Turtles game. I haven't abandoned Gimmick. I'm just decided to take a break from that and do something different. So I thought this could be educational, and yeah, we'll just see how it goes. So I haven't done a kind of programming stream like this before, so it'll be a new experience for me. But anyway, I'm going to keep the music on just as a, so it's not just all my voice. So anyway, let's switch views here. All right, good. So it looks like OBS has remembered the settings for this. Because yeah, when I was actually setting this up, OBS was being extremely finicky about a lot of this stuff. And hopefully this view works, but again, I can always tweak it if need be. So, one sec here. Gonna mute myself. Let's try this now. Looks like the mic was actually peaking a little bit. Turn that down just a little bit more. All right, so yeah. So what this project is basically all about is, take the game, and then take the binary data, and then just rearrange it in such a way that it becomes readable code and compiles into the original game. So this far, the game is 128 kilobytes worth of program ROM, and it's divided into 16 banks, and each bank is 16 kilobytes apiece. And so what I'm using is the same assembler that I've always used, and that's NES ASM. It does get some flack amongst the community, but it works just fine, so I'm just going to stick with it. And thus far, I've done a good chunk of Bank 0, a little bit of Bank 1. I found some data in Bank 3, although there's not much going on there. And then lower down is the fixed bank. So that's where a lot of code, which has to be executable at any time, needs to be accessed. And so let's go over to mess in here. So this is in fact the very game. And so I can do a few things with the game thus far. For instance, I have decoded the little copyright screen here, and I figured out how the actual text format works as well. So if I wanted to, I could actually modify this, because some hacks of games would typically place letters with spaces, and then you have your empty text there. But yeah, I could change the formatting of this if I wanted to. So we don't really have much in the way of chat here, so I'm just going to go with my original goal here, and I was going to try to figure out the music engine. And I found out that's actually in Bank 0. Seems like it has all the music and sound effects in there. And when you get to the title, I actually found the code which plays a new song. And if I wanted to, I could actually change the title screen's music to one of the other songs in the game. So I've been experimenting with that. But I want to figure out, how the game actually decodes the music data. And so that's what I'm going to go with. So effectively what happens is, let's open up fixed A here. Okay, good. And yeah, let's go with a little bit down here. So there's some kind of current state in the game. Yeah, update state. So what this does is it looks at the current state and then uses the table down here to go to the address. I'm in the code. So in some places where I obviously know what the code is actually going to do, I've actually assigned a label to it. In other places, like here, these numbers just correspond to where this code would appear in ROM, but later on I plan on actually assigning some proper labels to that. But the game only has 6 states, actually. You have the little intro screen, which is the copyright and title screen, which has a few sub-states. You have the little intro sequence where, shows that cutscene with the turtle introductions. And then the main game seems to have 3 states. Like this one is kind of like transitioning into the level, and then when it gets, I think it's here, where it actually then handles the main game logic, and then that's going to be a pretty big task all of its own, just to figure that out. Then the ending cutscene has its own state. So in theory, you could actually reset the game and then start from the ending if you really wanted to. But going down to here, which is the intro screen, it has a substate, and then the substate then has things like, prepping the copyright text. It displays the text for a certain amount of time, then it goes to the title screen, and then if you press start on the title screen, it blinks the cursor, which is this state, or not the cursor, but the press start text, and then it, goes to the game. But right here is where the title actually starts. So there's a little routine here where it basically keeps decrementing a global timer, and if it's finished, it then does something which transitions into the actual intro. But when this is initially called, find it here. Let me just look for E. So this code here, it's not labeled yet, but this is actually the routine which queues up a new song. So 4E, for example, is the ID number of the title screen music. And I even created a little document here which lays out the various musics in the game, as well as some of the sound effects that I was able to figure out. Some of them are not yet there, but those will come later. And one interesting thing with the music is seems like they have a combined music track, as well as a music track you can call, which only plays certain sound channels, so that'll be interesting. And so it's like that in sets, like they're 4 bytes a piece. We have the song, lead channels, triangle, and the noise. This little title alt is just the percussion only. I wrote use for cutscene. I believe this is actually used like in between levels, where it just has the little percussion playing, and then it transitions into the level. And of course, these are the other songs in the game, the overworld, and what have you. So yeah. So anyway, excuse me. Shit. That's one thing with VS Code. Yeah, you gotta pin the file there. So when it calls the song, it goes to this location, CEF0. Looks at so every bank at the very beginning of the bank has 1 byte allocated, which corresponds to an ID number of that bank, and then it just backs that up. So what it seems like it's doing is it backs up whenever you cue a new song or a sound effect. It backs up the bank into memory 59. I should assign a memory label for that. And then it calls a routine to swap in bank 0. And in the case of MMC1, they have these routines which properly swap in the bank. And then it goes down here. So I'm wondering if like 2F might be some kind of mute or ignore new song flag. I'm not sure. And then, so now that bank 0 is swapped in, this 90FC is actually where some of the magic happens. So go to 90FC. This is where a new song will be queued. So it looks like it's checking a couple things. This seems to be like if the song ID is too high, it'll just ignore the request. If you look here, game over is 8B, so you'd have C, D, E, which would be those sets here, and then F, I guess, would be an undefined song ID. And then let's see here. Oh, sorry, wrong. I have to keep pinning these. I have to pin these to the screen here. There we go. So if it's not out of bounds, so if it's, a number less than 8F, it'll continue. Otherwise, it goes to some sort of fail code. Looks like. And then 4B, which again, title is, sound effects. It's like 4B was like the bombs exploding sound in the dam. If you fail to get all the bombs in time, it's just an immediate game over. So it looks like there's some special case for that. Otherwise, it does a couple more checks. Like some resets. And interesting, it seems like it's checking certain song IDs for like some special code. Like if the mini-boss is defeated, it has some special code. If the boss is defeated, I don't know if that has to do with the fact that those songs don't loop, but it'll be something to figure out. I think it's wrong. It's not a turtle lost. What is 8.3? Oh yeah, it is. Yeah, there's a turtle lost. That's not a sound effect. That is a music track. So even those have some special exceptions. So let's just get into it. So let's so the title screen music is not any of those. So let's just look here. So it goes down to 90B2. Yeah, because it looks like those other tracks would have this code, and then it seems like they would just exit. So what it does then, some backups here of X and Y. It loads this address, which I even wrote the comment here. This address could have just been done with a high and low byte instead of, hard coding it into a ROM location, but whatever. And it creates a pointer. It gets the song ID. And what this is doing, it's kind of quadrupling the pointer here. So in fact, let's go into our debugger here. So we get down to code B2. So we're gonna just execute some code here. And wait for the game to loop the title. Oops, I didn't do the right breakpoint. Let's reset the game. So we can press start here too. So in our debugger here, down, down, down. So we're executing that. One sec here. So it uses the song index, and then it kind of like quadruples. And so here, we're looking at memory location 9275. We're grabbing the value of 18, which we got here. Shifting that right 3 times. So now A is 3. Or 1, 1, and then we AND that, so store that into EA. Now do a split screen here. Guess the split screen's not showing up too well on stream here, but well, so I'm gonna go back up on this side up to C4, or sorry, E3, which is here. EB was 0, shift right. So EB is still 0. Turns it to Y. Just in case we clear. One thing, whenever I do masks, I like to actually use this bit method instead of the hex. I mean, in some cases I do, but in other cases, when it's doing a bit analysis, I just find this easier to read for me. So we got that. So we have that. And once again, 0. So once again, this is current song ID. Compare to this. So carry flag is indeed set, so we're going to go down to here. No, 0, that's fine. So A and X are 0. Y is also 0. Y is now 1. So now we're going to look at our pointers here. Okay, interesting. So it looks like this might be an address. So I haven't figured out quite what the 1.8 at the beginning does yet. So it's storing this into E6, and then so it looks like 1, 2, 2 might be a low byte backup, and 1, 2, 8 would be a high byte backup. So we've now got a pointer over here that's going to be changed to 9A6 or 6.5. So what is 9A65? Let's go down a little here. So 9A. 1, 2, 3, 4, 5, 6. 2, 4, 5. A little label here. This is bank 0. 9A65. And now that we have a label, we can replace this. Okay. I just rebuilt the game just to make sure everything is in order, and it is. F8. So one thing with, because when I did the Gimmick music engine analysis, its engine memory locations were also 6 apart. So I'm not sure what this relates to yet. We have a 1. So this must just be some kind of prep for a new song getting queued up. There's the 3. So X has to be the actual sound channel in this case. I'm not sure which channel. Like, I don't know if they go in order, or if they use a different kind of ordering scheme. So if it's greater than 3, I'm guessing that's going to be for DPCM purposes. Maybe DPCM or noise. So if it's greater or equal to 3. 2, I'm going to guess, is maybe for triangle, question mark. Noise or DPCM. Maybe noise and DPCM, I should say. So if not, so they're probably the pulse channels. Okay. So I guess triangle is here. These must be some pulse specific rates. And then noise / DPCM. Although this code gets executed anyway, so I guess those channels must not need the resets. All right. So I guess we figured out at least the pointer. So in my memory map, so these are the. Let me close this inside. these are the memory locations that I've figured out thus far. Some of the 0 page. And then, yeah, TMNT actually uses, oh yeah, I guess I did figure it out. So let's, yeah, go ahead and replace all of these then. Music channel pointer low. Music channel pointer high. In fact, I'm going to replace these in messing as well. So we have channel pointer high, which is length of 6. Channel pointer low, which is also a length of 6. Go ahead and save my labels here. All right. Yeah, no clue these are just yet. All right, let's advance in the code a little bit. So we got down to here. Okay, so A is 0 in this case, so I don't really need a comment, but A equals 0. Yeah, this is just a, I guess, a shortcut. Instead of having to load 0 into Y, it just does that. So now, let's go back over to here. We're looking at our 9A65. Set pointer. Compare it to 3.0. In this case, we have D7, so that's not going to trigger that. Decrease Y. Remember, like the music memory, I think it gets close to the 9 or maybe even the A, like the 101A range. So that's some info stored at the end. So Y back to A. Again, you have to get into those where it's you have to actually get it to where it's actually starting to play the song to actually figure out some of this other stuff. In fact, I think I'm going to assign a label to that as well. We call something like music. Q new ID 94. Yeah, let's. How many times do we have 194 in here? 9 times. Is it ever indexed? Doesn't seem like it is. Okay. So in that case, we can place all of these. All right. Over. Yeah, okay. So it looks like it's backing up the ID in 0A. So yeah, looking over here too, when I was playing with this a little earlier too, if you set this to 0, it seems like it mutes the channel. So I say like This will be a mute flag. So this mute. Okay. I don't know that for sure, so that's why I'm going to leave the memory unnamed for the moment. Alright, so x is 0 in this case, so 0 pulse channels, question mark. So this is going to trigger. Go down to 8.2. Again. Okay, reload that. It's like a flag of sorts. Or no. Huh. So it flags 04. So this is always going to, you know. Let's go back over that. Step back, step back. So yeah, 1A is going to be 4E. Why would A be? Oh, because it's index Y. Duh. So maybe when we, it's like some kind of supplemental flagging. So maybe they're not always 6 apart. Maybe only certain ones are 6 apart. Or this could also be if a song is currently playing and it needs to change the song. That might be what it is. Possibly okay. Currently playing. So in this case it is 0, so this is going to continue. Transfer X back to A. Let me loop. I think. Shift A, Shift A. So X is definitely not 8. Some line breaks in between the labels here. Okay. So that's 3, 3, so some flags for the sound registers. Okay, then we up our pointer. Where's EB and EA? So I guess we're not actually opening our pointer. Ah, okay. EB and EA are some kind of indexes. So when do those initially get written? Alright, so we're not looping like some sound just for writes. Alright. So I'm thinking this is like a channel index. This might be a duration index. So I guess like it starts at 0. And then this would... So yeah, because deck, so that would start at 3. Okay. And then we go down to F. And I guess the branch might be out of range, that's why it does this. Okay. It's gonna go down here. And go to 903. So yeah, this is now 1. Shift, clear carry. What do I call EB down here? One more time. Channel index. Channel index question mark. And this triples the index. So it ships right, which is multiplying by 2, and then it adds the index again, so 2 plus 1. Yes, we don't need that. Come with that. Once again, transfer to Y. So now we're at 9278. That's going to be Okay. So it looks like these are actually in sets then. So we can, yeah, format this to be a little, oops, more readable. I remember Gimmick actually did something like this as well, where like it had these sort of indexes, the channels, and then some kind of pointers. And then down below here, So I'm wondering if this is just a table for all the songs. Because if you look at the data here, it seems like they're in sets of 5. Yeah. So you can even see this repetition going on. Move this over a little bit. Okay. Yeah. Let's make these DWs. So wow, does the title really use all of this memory? I guess it very well could. Like the percussion is repetitious enough, and that would be short, and the main channels would of course be long. Yeah, I'm even gonna, I don't have to do this, but maybe false channel view question mark. Triangle channel question mark. Noise channel. And EPCM channel. And this could be another song entirely. Okay. So yeah, in fact, let's find these in, well, here, let's get down to the code then first. Scan this to X. So yeah, now we're going through the same stuff again. And yeah, 9279 here. Will be here. Yeah, sure enough. Or is it sure enough? Oh yeah, 1.8, okay. Forgot you have to actually execute the code for it to actually be reflected in the debugger. So yeah, 9D18, 9D, okay, good. So where is 9D18? Probably should have found here as well, 9D00. Let's add some stuff to our memory map here. So let's do E6. we have sort of like a it's called music load pointer, and then maybe call music load channel pointer, and maybe call this music load song pointer. Something like that, yeah. B6. I don't have to actually do this, but just for readability for the moment I will. And then so was E9 used anywhere? I don't think so. You had EA and EB, just some kind of indexes and loading song, something like that. I'm not going to replace this just yet, but I've got the note here. It's not 2. So yeah, we're down to here. So now we're loading in our 9D18. Oops, 9D18. So I'm wondering if the FF here is the end of the channel. D18. And let's compile and compare. We're good. Seems like it writes these every iteration. So these are both temporary spots. So A is once again 0. X is 1, so don't need that. So I guess if it's 0, it's on post channel 0, or post channel 1. Because this is in fact going to go down here. And then this, I guess this for DPCM. Oh, I have caps lock on. For DPCM. In this case, it's not. So yeah, we're gonna then trigger. Rather, this would be for DPCM. So I guess this is for non-CM channels. Shift. So because we multiply by 4 here, yeah, transfer rate X, that's going to serve as, yeah, for this sound channel, right? Okay, that makes sense. I guess I'll just index for sound channel rights. Because, yeah, 4004 and 405, yeah. Okay. And once again, we're at E3 here. You know, I should label here, which I will do. Don't know how I missed that. In fact, since we did that, we'll save that. All right, continuing on. So now we're at 7B. So yeah, it's pretty much rinse and repeat, because it's going to make pointer to this 9F29. So where do I have 9F00? 29, I'm going to guess it's right here. Yeah. And then these two values are going to be in a different file, but do that when we get to them. All right. And yeah, right here, 9F29. So this case, it is going to trigger, so we skip this code. All right, let's run through this. Okay, it's not 5. Yeah, sure enough, it's 8. These are for the triangle channels. Okay, so it's good to know that the data does in fact go in channel order. So we're back up here. Once again, our pointer is now 927E. So I guess these are title screen definitions. This would be plus panel 1. Where are the question marks? So A0, A9. Right? Where's our A09A? A09A. Might as well do this one too. A1, 2D. Alright. Compile and compare. No problem. Alright, so it seems like we've got our initialization data underway. Yeah. It's gonna go down here. Shift, shift. A is now 12. Yeah, sure enough, there's the noise channel. Okay. Alright, so now we're actually executing this code. I guess after the 4 main channels are equalized, drop down. Now we're, yeah, restoring our registers, RTS. I could have sworn the title actually... Title also uses the DPCM, but maybe that's done separately. So then we restore our original bank. C5D9. This might be some kind of clear flag, I'm not sure. Alright, so that's, okay. That's then it for the song initialization. So going back to C3. Oh, hello Jake Station. Just read one email I sent to you in 2004. Biggest better. Oh, well, thank you very much. Yeah. Yeah, I appreciate that. I don't know if you've been able to catch any of the streams, but it's getting a digital release hopefully in the near future, I might have some announcements about that. If you check out 8-Bit Legit, where's the chat here? Where's the chat? This is one of the problems with these small monitors. 8bitlegit.com. You can actually see some information about the not some information, but they have I think they have a trailer video up there now. So yeah, I should have something on my own main YouTube channel coming up. But yeah, we can pin this to the screen too, just a little bit. Although obviously don't put the spaces in the URL like that. Haven't been in the stream for a while. Grinding some Mario. Oh yeah, I remember that. Lost Levels. Yeah, that was certainly a thing. That was certainly a thing indeed. But yeah, it's good to see you here. Yeah, tonight I'm just doing some code analysis on TMNT, the original NES game, trying to figure out how the music engine worked. So it's interesting doing these disassemblies of games, seeing how, you know, other people made the games, especially in some of these earlier releases. Sometimes there's well, I don't want to say like bad code, but like questionable code. So it'll be interesting to see when we get to that point. But yeah, tonight's main focus is just to try to figure out the music engine. How the heck, you know, this data, like how the heck, you know, Konami, or Ultra Games, as they call themselves, did the music. But yeah, you know, feel free to chat, you know. I'll just be analyzing in the background here. Alright, let's... People say the first TMNT game was hard. I think you're a little hack. Well, I mean, they're not really the same type of game, you know? I mean, TMNT is a platform game, Logo's a puzzle game. So... I don't know, I think challenging Lolo 2 might have been a little bit harder in some aspects. Yeah, I haven't played those in a very, very long time, actually. I think I'm going to move the chat. Yeah. It's kind of adjusting things as I go. Hack is harder than Lolo 3? Yeah, that could be. Lolo 3 was an official game. Of course, if you ever tried Lolo 2, the Japanese version, so because in America we got 1, 2, and 3, Japan had 2 games entitled The Adventures of Lolo. They had the Agerland mystery game before those, so that would be kind of like their Lolo 1, and then The Adventures of Lolo was the same engine as Lolo 2 in the US, and then likewise for Lolo 3. Hello, Mira Lupa. Can the noise channel's volume be adjusted on the NES? Yeah, it can have values of, you know, 0 through 15. It just depends on, you know, what you're playing at the time. Like, a common thing is to use some sort of what they call an envelope. So where you have, you know, in one frame we write a volume, and then the next frame we write a lower volume, because it's typical for notes to, you know, kind of start high and then fade out kind of quickly. Yeah, the noise channel has volume. It has something called, I think it's called short mode. I don't remember the exact name for it, but it gives it sort of that electric sound to it. If you're not in that mode, then it just sounds like the percussive sound. I don't know, we might uncover some sound envelopes as we go along here. So what is it? So yeah, thus far, I figured out how the songs get initialized. Like I found the pointers. So in this case, it's the title screen music. That's the first song you hear in the game. I'm guessing, oh, no, maybe not. Maybe the sound effect data is at the end of this. I'm not sure. Again, where was this pointer? Yeah, there was tables for the pointers, but well. Oh, you never played the Japanese lows? Yeah, they're definitely harder than the American versions for sure. Lolo 2J, as I call it. Yeah, especially when you get to the later levels. They make you do some really tough stuff in there. Let's see here. So, all right, so we've exited the update states, so now we're going to be on the title screen. So let's in fact put a breakpoint here, advance 1 frame. And so every frame, after you set the scroll, I believe it's this one. Yeah, because we go back in the bank 0 at CED5. So going back into the bank 0. And eventually we're going to get to 8644. Yeah, I think this is what then continues the song. So it seems like when it initializes it, it puts some kind of flag in the memory that a new song is starting. And then for the pointers, it then writes the pointers, and then it's most likely going to be looking at the pointers to the music data and then updating as it goes along. Okay, so that makes sense. Let's actually put another breakpoint down here, skip this code. Oh wait, let's put a pointer here just in case. It looks like there's a branch that might skip something. Alright. So we load into 2F, which is 0, so this is not going to trigger, okay. And now we're going to 8644 here. Yeah, I guess we don't need the... You know what, we don't actually need the fixed bank. What am I doing here? We don't need the fixed bank in view anymore, so... One more time, go to 8644. And immediately we JSR to... I guess there must be a reason, because I guess... I don't know why they wouldn't just jump directly, but... I guess there's maybe a reason why... Oh well, whatever. Figure it out as we go along. Alright, so we're gonna go up to... 8612. So this is some kind of flag. Some kind of like a... Wait. Okay, this must be some kind of skip flag. Okay. Because yeah, this is going to immediately exit and take us back to 4.4. Alright, so we're back at 4.4. X and Y are 0. See, I think I was actually looking at this earlier too, that's why I have these comments. So it backs up the current indexes of X and Y. These might also act as some sort of iteration counts. Okay, what comment for 1 away. Yeah, so this is like some kind of channel flag, it looks like. As we go along, I'll actually assign proper names to the memory locations. Alright. So, okay, back those up. Look at our flag, which is 4E, which is the same ID as the title screen. Right here. This is clearly not 0, so that's going to go down to, yeah, play. I think, at least I think it's play, but yeah, it seems like nothing else even JSRs here. But whatever, okay. So yeah, if nothing actually JSRs to here directly, then whatever goes in here could probably be put here, but I don't know that for a fact, because there may be a reason why, you know, we don't execute this code, so it would require further analysis. So anyway, we're going down to 8F96. And then we write okay, so not only were we we're storing the currently updating channels pointer. Alright, so yeah, I even put comments here. So E0 and E1 are maybe like currently updating channel pointer. That'll be our tentative name for the moment. Go back. So I'll put a little comment here too, create pointer to updating channel. Not sure what this is just yet. It's 0, so we're going to jump. All right. So A is still going to be 0. So we're shifting A, which would of course the carry, put the 0 bits into the carry. In this case, it's going to be clear, so we're going to drop down. This is not 3. So now we're actually looking at the, so I'm going to open another instance of bank 0 on this side. Shouldn't close that. So now we're actually starting to look at some of our song data. Is at 9A65. So we're at the beginning of our song data. It's D7. Compare to C. So this is one thing games do, and well, might do in their song data, is like the numbers obviously mean something, but typically they might have high numbers to represent effects in songs. That could, and effects could be any number of things, like as we were talking about earlier in chats, maybe they set some kind of envelope on the channel, which would determine how each note gets played and like the volumes. So some kind of like volume pattern. They could be things like, how long is the note supposed to play? So in this case, we have D7. It's doing this comparison to C0. So in this case, it's going to drop us to here. And now we're checking these two bits. So we have D. And then now we just have 1, 0. Shift this right 3 times. It's going to give us a value of 2. Yeah, A is 2. Transfer to X. And now we're loading from a data table. So 8FC4. In fact, I think I'm going to put a label in here as well. And this data table is 32 bytes long. So it looks like E2 might be a pointer for the effects. So there's sets E2. Maybe like music effect pointer or S2. Again, I'm just guessing, so I'm not going to actually assign the names in Messen just yet. I did do some label updates, so I'll save that. One more time. Oh, it's an indirect address pointer. Interesting. All right. So we're creating a pointer to 8D22. All right, so yeah, these are, yeah, okay. I even called it an address table on the side here. So it's here. This is one of the kind of tedious parts of this, is having to rearrange these bytes. I do have a tool when I have like big chunks of this. It does it automatically, but for now it's fine. So 8D22. D22. All right, so I don't have a label for that. So 8D22 goes here. And it looks like the above code ends up there, so we'll put a separating line here. And we'll put a label in missing, so we've got it. So we clear these bits. So this apparently stores a value from 0 to 15. Okay, this is making sense then. Actually, why am I doing this on the right side? Let's go back down to our pointer. Because yeah, what the effects do. So this I could actually redefine this as C0 plus 17, which of course evaluates the same number. So like they typically have, you know, some kind of ID, and then these you can almost think of as some kind of arguments. So that's where this 3, 3 is coming from. And then X is the current channel. What do you call it? The current channel that we're updating index. So this is like a special case for the triangle. Check the triangle. And if it is, then it does some special code. In this case, it's not, so we're gonna just drop down. And then we're concerned with some line breaks in here. We're concerned with the upper 4 bits. So now A is going to be 3, 0. It's going to be in whatever 158 is. And then these are the lower bits. All right. So 152 and 158 are some kind of set that relates to this effect. We increase our pointer again. So now we have this value of 8, 1. So I'm wondering if possibly this set has 3 arguments, because these look like these over here look to be other effects. Don't know for sure just yet. All right. 164. So we've got 8, 1. I guess some kind of effects. followed up by so many values. Figure that out in a moment here. So 8.1 is not a plus, so it's going to continue. And this is just going to always branch. That's one thing I noticed they do in the TMNT code is they just load a value and then branch instead of just jumping to the address. That actually saves 1 byte. I think it even saves a machine cycle if you do it that way. The only downside is you can only go to a code that's close by with a branch. So, okay. So we go to here, that's 0. We increase our pointer again, okay. Copy this. So yeah, now we're getting this value. So I can clear the bits. So 6.8 is going to just be 8. Reload our pointer, so we're reloading 6.8. So shifting right 4 times, we're going to go 6. It's kind of weird that you store it and then reload it. Because, I mean, A is already, you know, this value. And, I mean, and shifting would set the 0 flag regardless, so... Not sure why this reload is necessary. Anyway, A is still 6, so that's a non-zero number. Okay, so this is where this ends. Some dividers here. We increase our pointer. Alright, so this takes 3 values. Figure out more what the values actually do later on. Alright. So we go back to 8925. Seems like a lot of these effects go back here, so this must be some kind of like after an effect ends, they return here. Since we indirectly jump to the effect, you have to do something like that. Okay, so 0 is definitely not 3. Okay, so yeah, when the effect returns that, it then reanalyzes the pointer. So maybe we'll write this better. We'll analyze where the pointer is. Checks for effects. pattern effects ends, they return here and check what follows the effects. So you can chain effects too. So I'm guessing since this is the title screen music and it has that percussive intro, I'm wondering if CF is actually a rest, and then this might be something like a note length. Because there we once again loaded end, which is CF, compare to C, and it is in fact greater than that. So in this case, yeah, C, and then clear these bits, so then that would in fact, yes, be 0. So now we have effect is 0. Once again, looking at 8FC4, we have effect is 0, which is 8CBF. Did I have a... Oh, I did, good. In fact, let's put this right here and put this here as well. So we indirectly jump to 8CBF into a 0. Oh, sorry, we do a JSR first. I do not have a label for this. I will define one. So I'm wondering if this code is something like playing the notes, or in the case of a rest, it also has to play for a set period of time. So one sec here. Okay, that's not going to trigger. Take this value and add it onto itself. So 7 plus 7 is 14. Decrease. Oh wow, I'm really missing labels here. So that's 8C, 7C. Which is right above the CLC command here. And also 8C, 8, 9. Save these. Alright, 8C, 8, 9. It's here. Just build and compare to make sure. All good. So that is in fact going to trigger. So we keep increasing A. This is weird. So we're going to increase A a couple more times. It is in fact 0 now. So this branch will always trigger. Go down to 8, 9. All right. So we store whatever A was. This checks if it's the triangle. Or no, it checks if it's triangle, noise, or EPCM. In this case, it's of course not. So that was 0. So that's going to trigger. This checks if it is only the triangle. Of course, it's not the triangle. This checks if it's the noise. It is not. And jump to here. Wow, okay. This will take some doing for sure, just to figure it all out. So that becomes 0. It's not going to be minus. Wondering if E2 and E3 are not just for the effect pointer, but some kind of temporary memory that this uses. Because like they're clearly not using it for pointer purposes up there. So the 7, 0 was the value we just backed up. So we're adding 0, so this were to go over 255, then the carry flag would be set. In this case, it's clear, so we're going to come back up. In this case, it went over. This is going to trigger as well. Oh man. Man, this it keeps like adding and repeating a bunch of times. So back over here, C7. So E5 in this case is some kind of iteration count. And E4 is like some kind of accumulator. So it does like some accumulations a certain amount of times. Okay. Guess I went a little too fast there. Back up. I guess E2 is also like another iterator. Oh, I guess since this is defined first, we should call this some iteration count. Yeah, what wound up happening was E2 went under 0, so now we're down to here. And eventually A became 8-0. Shift left. So that puts the upper 4 bits of A into E5. Reload into E5, return. Now we're down to here. So this is in fact separate code as well, so we can split this. So eventually that became 3-8. Going back to, I'm missing a label I'm missing. So back to 8CFB. is in effect possibly a rest. So I'm wondering if what that did is like it calculated like some kind of tempo and some kind of note length, and then ultimately how many frames it's supposed to hold before advancing to the next note. Because that would make sense, because the code looked like, you know, when you go to here, like above here, it looked like there might have been another way you can execute this instead. So there might be some kind of tempo and some kind of note length that we wound up setting. Although then again, it could be like the gimmick music engine where they just have like, you know, weird note lengths, you know, like note lengths of 5 or 6 instead of using numbers in the tempo. So again, I'm not sure just yet. Anyway, slowly 0. Check if we're in the triangle. Sorry for the background noise there. In this case, we are not on the triangle, so we're going to go down here. So it seems like, yeah, triangle actually gets its own follow-up. Now we go to here. Backup A. Here to 0, so that's that is what's pulse channel 1, so sorry, I have to check this message here. 1 sec here, sorry. All right, sorry about the... Okay. So if we're on pulse channel 1, go down to here. So I'm guessing this must be for... Wait. Can we call this... I don't get why we would want to re-index X in this case. So anyway, this channel 1 comes here. And then this, what this does is it returns clear. So it's kind of like a Boolean function, which is another common way some subroutines get done. Turns clear carry, if not pulse channel 1. Spell pulse correctly. Otherwise set carry. So we're gonna go down here. Or no, that's actually not entirely right either. Oop. Hello, arm pulley. Yeah, doing pretty well. Thank you very much. Thanks for coming in. Just doing some code analysis here. Hope you're doing well too. Yep, just trying to tear this whole thing apart and see how it works. So, so if you're on pulse channel 1, this must be some kind of flag. Alright, anyway, let's execute this. So that's going to go back up to here. It's going to return false, or carry clear. Turns carry. There's a kind of true, false. Oh, you've done the speedrun from the game? Yeah. A lot of people like to speedrun this game. I know that. Yeah. Right now, what I'm actually doing is disassembling the music engine, just to figure out how that works. Because that's one thing I find interesting about games is like how they do their music and sound. Like when I did Gimmick, it was pretty complicated, and this one also is kind of complicated thus far. So I'm at the point where we're actually updating the sound channels. So I've determined how certain effects get called. And right now this seems to be a note rest effect, which is, just pausing the channel for a set amount of time. And it seems related to the actual, what do you call it? The notes themselves, like they're probably use some of the same logic. But yeah, maybe we'll figure it out, and then we can maybe make custom music for TMNT. So let's see here. So this comes back. So in this case, this function will return carry as a bool of sorts. We've done some 6502, but looking at sound code is... Well, all it really is it's just like analyzing some data. Maybe I can... not here. I just realized I'm doing this in the right pane again. Why am I... Here, put this on the left pane. Here we go. And then on this pane... So like, for example, this is part of the title screen music. This is data. And what happens is, if you have a value that is greater or equal to C0, that means some kind of effect. That's just the way that the Konami music engine for this game was made. So what is it? So like C0 is affected. I'm guessing after we get to some point, we're going to run into numbers which correspond to the actual notes. In the title screen's case, it has that little percussion intro, and so it would make sense for it to have the rests And then eventually it's going to get into some kind of notes for the main channels. But, you know, still, you know, you gotta figure out the parts little by little. Zelda 2 has 2 sound engines, one for the title screen. Oh, interesting. Yeah, I think I kind of noticed something like that with this game. Let me take a drink here. Like, when a song is initializing, they actually check some specific song IDs. Like for the, like the victory musics, like when you beat a mini-boss or a boss. And it seems to be something like, what do you call it? Like, because those are songs that don't actually loop. So I think it has something to do with that. Like, it has some special code for those songs. They all seem to get run through the same engine, though. But yeah, when we, you know, get to those songs, we'll see if they, in fact, do use the engine or if they have some other special cases. But that's 2 different teams working on the game. Yeah, it could be. I've heard of some analysis of the Zelda 2 code, like especially when they converted it from the Famicom disk system back to a cartridge. And the cartridge used MMC1, and apparently it does a whole lot of bank switching. And it's my understanding that the bank switching is kind of inefficient, because when you do bank switching, you want to, you know, stick with the bank as much as possible. But it was kind of like jumping all over the place, so maybe they didn't have time to optimize the code for bank switching. That's my guess. But kind of looking at this data, like this code is probably something that sets up a note length and possibly a tempo, and then CF, I'm almost positive, has to be a note rest. So I'm not quite sure what in these values is the note length. I'm thinking it might be the 3rd one, but again, I don't know just yet. Yeah. Yeah, I actually disassembled the Gimmick music engine as well. And it had kind of similar things, you know, with the high numbers for the effects. So yeah, we'll let's see what we can find. So in this case, so we're trying to carry the flag of clear. So I'm wondering if it returns a set carry flag, if that means that there's a note actually playing, and then that gets written to the sound register. Otherwise, it just skips writing to the sound register altogether. Yeah, maybe write that down. So like, if carry is set, possibly denotes writing tone to sound register? Question. Hopefully, hopefully you can see everything okay. See, I just set this stream layout up last night. I would guess Gimmick is a lot more complex. Well, because the game uses the Sunsoft 5B, and that has 3 extra sound channels. I noticed that a lot of the logic was the same. What it kind of does is it runs through the 4 main channels, then it runs through the 3 extra channels, and then it does the DPCM last. But for all the channels, they had a lot of the same kind of effects. Things like note rest, note length. It had things like vibrato, stuff like that. But yeah, it was pretty big. I mean, looking at that entire game, not just the sound engine, but all the music data, I think was close to something like 40 kilobytes. And, you know, the entire game is 256 kilobytes. And the DPCM samples were actually across 3 banks, so that's another 24 kilobytes. So yeah, it's got a lot of stuff. Sunsoft really cared about their music. But anyway, Or no, carry was clear in this case, so we're still writing to the sound register. You're writing 3-0, and I noticed that 3-0 was, yeah, I'd have to look at what, you know, the actual numbers mean for the registers. I don't know them offhand. It's a bit-by-bit thing. 3-0 might just be no tone, so actually not if carry, so if carry is clear. Let's read the notes writing, no, maybe writing silence to the sound register would be a better comment for that. Layout looks good. Can only see left half of the right side. Yeah, because VS Code is so big. You know, I mean, I kind of like have the main code over here and then like some supplementary data over here. I mean, if I really wanted to show it, I mean, I could do something like this, but this is more for like just data analysis. Anyway, let's field and compare. No differences. Good. But anyway, yeah, thanks for saying so. Yeah, because yeah, I was thinking of making the the middle window here with the VS Code a little bit wider. The only problem is that would shrink the two windows on the right. Not sure how well common code can be distributed across the banks. Almost have space, but banks haven't. Yeah, because common code. Let me think about this. Oh, for Zelda 2. Yeah, I don't know if Zelda 2 is 128 kilobytes, but if that's the case, Bank 7 would be the fixed bank. It would make sense to have as much shareable code in that bank as possible. Like, in the case of Gimmick, what is it? Well, Gimmick also uses a different bank switching scheme, though, so it's not really the best comparison, but in general, like, they would have banks dedicated for, you know, music. They have 7 banks dedicated for the level data because there's 7 levels in the game. And they have a bunch of banks dedicated for the objects, like the enemies. They had a bank for the title screen, as well as the intro and the sound test. Those were all in one bank. They had another bank for the good ending, another bank for the bad ending, and the map screen. So yeah, it could be just a matter of, you know, putting data where you can, but I'm thinking in Zelda's 2's case, since it's all over the place, they probably just, you know, put it wherever they could, and what was I gonna say? They probably just put it wherever they could and then just didn't have time to optimize it. I don't know. It would be an interesting thing to ask if we could ever find the developers. So the title music is in Bank 7, but it's in Bank 6. Yeah, I'm wondering then, maybe the music and sound was too big, so they had to put it in Bank 7, and then maybe have special code for playing it in an irregular bank, would be my best guess. Because yeah, like the only other solution is if you had a bunch of music is you'd have to put your music bank in a place where it could always be accessed. And then you could, you know, of course have other banks for the music. Because I actually do that in the BattleKit games. Like the music engine is in the fixed bank, as are the sound effects. But the music tracks themselves are in several different banks. But all right, so we write 3 zeros. That's like a silence thing for the square registers. So we... All right, so this is like reloading our channel index. this for whatever reason. Just a thing that I like to do in my code, whenever I use the AND or exclusive OR, I prefer it to be in this binary data most of the time. It's just, I find easier to look at the bits that way. I know, you know, hex is a shorthand, but it's just something I like to do. That's why, you know, I'm doing that. Alright, so we do that, store that. Then we go back up here. So this is like our, yeah, repeat points. So this point, channel, pointer, and check next spots. Actually, this can, yeah, this can be divided. Is the one, yeah, well, the stack is always in 1, 0, 0, but 1, 0, 0, when you push to the stack, it goes to the end of the stack. So like if you push your first address, that's going to go to 10 FE. Because this is like a memory map. Like this assigns, maybe put this over here a little bit bigger. This assigns names to the various memory spots. And the music engine kind of goes up to, what do you call it? To around like 10, almost to 10A0. And the stack usually doesn't get more than like 8 to 10 addresses pushed over there, so it's a non-issue. If you're pushing a lot of stuff onto the stack, then it can become an issue. So you have to be really careful if you're going to use 1, 0, 0. E.C. Myers, Christ on the Battlefield, excellent. Oh yeah, thank you very much. Yeah, so yeah, if you don't know, can pin this to the screen again. So on 8-Bit Legit, there's a trailer video for the Battle Kid digital release. So it's actually going to come out on Xbox first, and it's going to also be on itch.io, so you can be able to get a ROM to play. I should have more information about this in the future. I don't have it just yet, because I don't know the exact times of everything. But yeah, it is coming. So yeah, feel free to check that out. All right. But yeah, it borrows, yeah. Yeah, if you're gonna use 1, 0, 0, you have to just be careful with it. I mean, you can use it, you know, it's memory. Hope whatever you're doing will help me finally beat TMNT. Well, I mean, I suppose, for example, I could give you 99 continues. I could, you know, make it so the turtles only take, you know, half damage. Things like that. It's possible. We'd have to just get to that point of the code. I was an early adapter because, oh, thank you very much. Yeah. Hopefully you can be a new adapter, an early adapter to the digital release as well. Yeah, version 2.1. It's the Famicom version with some extra stuff in it. There's new music track. What else was in there? Well, you'll see. You'll see. That's all I'll say. But alright. 8F86. So we once again increase our music pointer. In Y, transfer Y to A. Oh yeah, this makes sense, because Y could be any number of values depending on the effect. Because, yeah, and Gimmick did something like this too. Let's go back to the data here. Sorry, not here. Actually, we don't need this help anymore. So like in like some effects case, these are kind of like arguments. So you want to actually not only just add one, but you want to add the amount of arguments as well. So that's why they're transferring Y back. Transfer to A, clear it, store it there. And one thing you can actually, oh wait. Yeah, I'm actually going to put a note here. More efficient. Branch of carry flag is clear. And ink. See, when you're incrementing a pointer, I mean, of course, you know, adding with carry 0 is a viable option. But one alternate way you can do it is just BCC, kind of like a skip. Because, you know, if this doesn't wrap 0, if it doesn't go above FF, then there's no reason to, you know, do this addition. So you can like BCC and then increment it, like INCE1. That's just a shorter way you can increment a pointer. Anyway, what do we got here? Reread your review of Battle Kid. Oh my goodness, we have reviews? You'll buy the ROM? Oh, thank you very much. Managed to get the Famicom card from PlayAsia. Yeah, because they only made like 3,000 of those carts, and they didn't make any more. So right now maybe the best place if someone wants to get it is on like the Japanese version of Amazon. Oh, you wrote one? It's possible I read it. Where was it posted? Alright, we're gonna up our music pointer. Turn. See, now we're backed up to 8659, which is here. Alright, so that function, it incremented our pointer and it knows that the effects are now finished. So, in that case, this code then goes onto the next channel. On a personal blog, okay. Well, if it's still up, you can always send it in a PM here on Twitch and I can take a look at it. But yeah, we increased X and compared to 6. And I wrote a comment here. There's not really a reason to be, like, I think BCC is a better, or sorry, BCS. So that way, like, if it was ever greater or equal to 6, we just exit. But I guess it will always be 6, so it's not an issue. Oh, your wife must have bought one of the last Retro USB for Father's Day. Yeah, it's unfortunate that they discontinued a couple of the arts on there. Need a drink. But yeah, with the new distributor, we'll be looking into getting some new carts, hopefully in the future. Again, I don't have any info on that yet, so I have no timetable. Had to take a break, but I'm in the final area. Oh, nice. Yeah, be sure to play the special stages if you can. So anyway, yeah, we go on to the next sound channel. So in this case, it's not 6. Barracks to 5. So this must be for the DPCM, I'm guessing. But anyway, we're not on the DPCM, so that's a non-issue. Transfer away, shift, and transfer you back to Y. Go back up here. We back up our indexes. Okay, put a note for that. So kind of like when it's updating, 0192 and 193 are kind of like music engine backup. So we're backing up our X and Y registers. So I'll probably assign these names to these memories afterwards. But yeah, it's good that we're slowly but surely uncovering more of the memory, figuring out what it's used for. So now, X is 1, so that's pulse channel 1. So we're going to, once again, set up a pointer to pulse channel 2, which is at 9D18. And sure enough, 9D18. And wouldn't you know it, we've got some similar code. Let me see here. In fact, we might even... Yeah, we actually... Well, no, not quite. It's not quite the same code. But we have another D7, which was D0 plus 17. Later on, I can assign actual names to these music effects, but as we know, that particular effect took 3 arguments. And we'll, I guess, for consistency, we'll put them on one line, although figure out how I want to format this later. And it makes sense that it would be similar because, you know, there's no lead at the beginning. So in fact, let's go back here. So when we initially... You know what I'm going to do is actually, since we already went through this code, there's no reason to go through it a second time. So let us... put a breakpoint here. We're going to skip the code, and then... So now X is 2, which is the triangle. And yeah, that also has a D7 with 1 argument? Ah, yeah, I think I remember when we were looking at that effect, it had some special conditionals for the triangle channel. So I guess in the triangle channel's case, it only takes the 1 argument instead of 3. Not sure how I feel about that from a coding standpoint, but okay. Because it's like when you call a function, well, yeah, I guess it could be optional arguments. So I'm wondering then if this is some kind of note length. Like the first argument might be the note length or possibly the tempo. Well, no, that wouldn't make sense if it's the tempo, because the tempo should be for the entire song, not just each channel. So yeah, this has to be like a note length of sorts, 2-0. And then we have the rests here, because it's just the percussion at the beginning. So now that we know that, I'm in fact going to, once again, skip the code and get to the noise channel. So now we're going to have some actual notes. Probably going to go for like another half hour or so, and then probably going to call it because it's going to be 11 o'clock here soon. So yeah, let's see if we can go through the noise channel. So compare X to 6. It's not 6. It's not 5. Transrate of Y. Jump. Back up. Did I screw this up? No, I didn't. Okay, never mind. Yeah, okay, X is still 3. So yeah, we're gonna JS already here. And in this case, we do need this open. Let's open a comment here. This is the title screen noise channel. So make a pointer to A09A. That's what this is over here. And then 867F. Or no. Oh no, we're in a different place now. Okay. 891F. My mistake. Shift to right. Does nothing. Well, it does something, but... So in this case, load in backed with X. I'll assign the memory name to this later. Greater 3, in this case it is 3. Alright, so this code can be divided. So this is for the noise channel. So we look at our effects. And it does, yes, similar logic. So the noise starts with FD. Okay. Do I not have a label for this? I guess not. So we're at 8E66. So let's create a label for that. So 8E66. Save that. And in fact, let's go back in the of having these hard-coded jumps. Use the label. Compared to E, it's not. It's less, it's going to jump. Or rather branch, not jump. I'll have to put a label on 8F10 as well. 6F. Compared to D, in this case it is D, or 13. So I'm wondering if noise has its own set of effects. That could be the case. So again, put a small divider here. Well, maybe not, because the code is kind of related. Alright, whatever. Alright, so here, we're increasing our pointer. Coming back. Okay, this definitely can be divided. So we're adding onto our pointer. Okay, we're adding, but we're not actually storing the pointer. Okay. Or rather, we're not storing the pointer in the pointer memory. So we're adding 3 to our pointer. No. More relevant would be here. Adds onto the pointer and backs it up into these 2 spots. To A09D. So that's B. So it's going to go to here. Let's put a small A09D. Open this. Man, I'm missing some labels here. So 80 C5. Let's define this one missing. So 80 C5 between these 2. Man, it keeps jumping all over the place. Oh, okay, I think I get it. So now we're actually changing where our pointer is. Okay, so this is actually an address, A100. In that case, so what I think it's probably doing is some kind of like repeating of a pattern. So that's a common thing in some music engines where they'll go to some pattern, like in this case A100, they'll play some notes, and then there'll be a flag to exit the pattern, and then we return to like this point in the song. So that's used to compress music data. And that would make sense because, like, you know, drum patterns tend to be repeated, like, because if you think about the intro title, it goes like, it has that same drum pattern over and over again. That's probably what FD signifies. It's like a jump to subroutine. Interesting. So in the case of 8F9.6, so yeah, those backups that we did, you know, let's go backwards in the code real quick. So before we came here at ATC5, and yeah, even prior to this. So this is probably some kind of, yeah, jump to subroutine. So kind of like a JSR to pattern in song data. Backs up, I'm sorry, adds 3 onto, am I right? Am I writing this in the right spot? Go back one more. Yeah. And it would make sense to add 3 because, you know, you have the byte and then the address, and that's 3 bytes. So yeah, you'd want to advance 3 in here. Hits 3 onto the song pointer and backs up so it can be retrieved. So you'll play your pattern, come back, and then reset your pointer to here instead. Okay. We got it. We got it. So then in that case, 8F96. So rather than this comment, like store the parent, it kind of like repositions the song, the current channel's song pointer. Because there can even be parts like in songs where not even like a jump JSR, but more like a jump, like you can jump to a specific spot in the song. That could be, for instance, maybe at a song with an intro, and then maybe at a variation where it skips the intro. Maybe that's not the best example, because in that case I would probably just have the song start, but you could do something like that, though. Or maybe like do your inits and then just jump and then reposition, and then you never return in that case. So no, yeah, we back up our song pointer. Well, let's see. ATC5. Load in whatever this was. I'd have to figure that out, but... Alright, so we're back up here where we're checking effects. And now we're loading our pointer, which is here. So this is at A100, which is D1. So we have effects within our pointer, or within our data that we jump to. To D0, it is not D0. So we're going to get rid of these, get rid of the upper 4 bits. So what the heck was D1 about? All right, well, continuing. Though I'm having something I'm remembering here. Because I think Konami Games did something where the noise channel, instead of having like percussion like instruments or like volume patterns, they actually treat the drum samples as sound effects. Like I've heard of that, like you can have sound effect data within the music data. I'm wondering if that was the case. So we have FB. Is it greater than F? Yes, it is. Or rather, is it equal to F? 0? No, it's not. Or no. What? Oh, sorry. We clear the bits. So yes, it is equal to F0. So we load in our pointer, which is FB. Clear the upper bits. Now it's B. And we're at 86.6. Is it greater than E? Or sorry, is it equal to E? It is not. Is it less than E? Yes, it is. Is it equal to D? No, it's not. Is it equal to B? Yes, it is. Only notice that they use the same pause sound. Yeah. That's Konami for you. Hey, with enough decoding, we could actually change the pause sound. So this is B. Transfer away. So are we once again changing the pointer? Yeah, well, I said we could do it. We don't have to do it, though. So we're once again backing up the pointer address. So are we doing like a jump to subroutine within a jump to subroutine? Back up. Parents pointer. Possibly another TSR. Question. Compared to yeah. It's possible they may even use the same sound engine. You know, I mean, it would obviously be different addresses than this, but yeah, very, very possible. So 8EC8s. Of course, I don't have a label for this, but okay. This is clearly going to end here. But yeah, you know, please tell me if you enjoy this kind of stream, because I certainly wouldn't mind doing more of them in the future. Even if we are going at a kind of a snail's pace here. I was kind of hoping to figure out when the notes actually play, but I don't think we're going to get there tonight. Also for next stream, I'll have to be sure to have more music tracks for the background. Let's see. Let's place these. Let's see here. One sec here. Forgot to do that. That's kind of important. Okay, data is still the same. Save our labels. So now we're in 8ECE, or sorry, C8. All right. So once again, checking. I have to figure out what 116 is supposed to be at some point. So my shift carry is clear. So we're going to jump. So now the pointer is at 8A102. We have, in this case, B0. So it's definitely not F0. It's definitely not D0, it's B0. Alright. 8C71. So once again, clear the upper bits. So B0 becomes 0, it branches. A is now 1. 1 is not greater than 2. Wait, what? Oh, sorry, X. X is, yeah. Okay, we're not on the triangle channel. You're a programmer, but enjoy streams like this and watching some. Okay, yeah. Well, thanks for saying so. Yeah, I talked to some other people about this, and they said they'd be interested. It might just be kind of a bad time because the only reason I'm able to do it tonight is that I'm actually home alone, so it's quiet here. Because ordinarily I wouldn't stream on weekday nights, especially not this late, because other people in the house. Sorry. But yeah, normally I would stream on Sundays. Although I'm wondering if I should have, like, you know, maybe a weekday stream for programming because it's more of a quiet activity. And then maybe, you know, the Sunday for playing games. Although I will not be streaming this Sunday. Endlessly interesting seeing how people have different approaches to reverse engineering. Yeah, I mean, really, you can kind of only go one line at a time, especially in cases like this. I mean, there can be cases where, you know, I can make assumptions about things. You know, like when the title, you know, it writes the copyright text. I mean, I pretty much knew there had to be some kind of, you know, kind of typewriter way of doing that, like where you write so many things. It was just a matter of figuring out where that was and how it works. But once you actually decode those kind of routines and you see them again, then it's like, oh, okay, this is clearly going to use, you know, this sort of, you know, writing routine to do this, and that just saves some steps of the process. And not only that, once more memory names get uncovered, a lot of things can make sense a lot more quickly. It's just that only, I don't know, I've only got maybe like 40 or so memory locations uncovered right now. Anyway, so 2 is the triangle. We're not in the triangle. 3 is the noise. We are in the noise. We're going to JSR to here. Oops. What is this? So we're going to JSR to here. We're going to up our pointer. So now our pointer is... Wait. Now our pointer is back to A100. Decrease Y. And go to 8972. So now y is 2. That is weird. Alright. So I do not have a label for 8972, which is here. So now we're loading in here. B0, shifting right, so we're at B. B is not C. Alright, transfer A to X. So that's B in this case. Stored into 195. Alright, so B0 is going to then become B eventually. And then B, which is 11, of course, is going to be an index for another table. You found that you need to name things a lot more often. Yeah, like kind of in the memory map here, I'm pretty sure, like, you know, that's what this stuff is for. When I get more info, then I will for sure, you know, commit the names. But, you know, I mean, the notes are here too, so I've got a pretty good idea of what I believe things are supposed to be. So anyway, so 89C1. Let's open up this again. So where is 89C1? All right. I'm going to make this just for readability purposes. So that's index 11. Which is the very last one, which is 8F. And we, once again, restore X. Compare it to 8F, which it is. Yeah, this is one of the slow parts about music engines, is when the songs each get initialized, they have to do a lot of things before they will start actually playing anything. Alright, and this was, I guess, some memory I figured out. It's like there's some kind of a cue, like a music cue. Subtract 8F. I think the reason why it's 8F is because that's the highest the ID can be. So 8F is the highest index for music song IDs. Because I showed earlier in the stream, I have this document here where I was looking at the various IDs, and Game Over is the last one at 8B. But each song has 3 extra things to it, where you have like the song is 1, and in the title's case, you have like the lead channels only, the triangle only, and the noise only. So in the case of Game Over, you'd have the complete song. Then 8C would be the lead channels, 8D would be the triangle, and then 8E would be the noise, and then 8F would be basically out of bounds. Like that ID wouldn't exist. So that's has to be alright. I'm gonna actually. Okay, these are most definitely not DMC rights. So think it's something to do with sound effects. Question mark. And then 8F, the boundary. It's the upper boundary of music song IDs. I will clean up the documentation later on, but so we transfer right away, back it up. So take this index, shift right twice, or sorry, shift left twice, transfer back to Y. Okay. Wait, what? No, this is DMC rights. What the heck? Okay. I guess it is something to do with DMC effects. Huh. So if that's the case, then the index 3 is not the noise, it's the DMC. What the heck? Alright, so very interesting. So now in the fixed bank, we have some lookup table at almost all the way down, FE41. So data, fixed FE41. And that has a length of 4. So these then I wonder if Turtles only has only one DMC sample. Because this right here, actually here, put our label into play here. Yeah, do these. So it's +1, +2, +3. Because this DMC address, so the sample has to be located somewhere in the fixed bank. I know that for sure. Because yeah, the DMC address is a really weird one where it's some number, and then that number gets multiplied by 64. And then that is stored somewhere in the C000, basically in the fixed bank in this case. Yeah, I'll have to look that up later, but wow. Okay. So maybe there's just the one sample. Alright, well it's 11:30. So you see if we can get to the end of the loop and then we'll call it. So go on to the next channel. So yeah, we can get rid of the question marks here because it most definitely is music engine related. Oh, I was really not expecting that. So I guess... yeah, I guess ultimately that became the EPCM channel. And I guess this must be the noise channel. So now we're gonna go to 8 cc's. Y is now 12. Alright, sorry, Y is now 6. And we exit. And yeah, we are now out of one iteration of the loop. Well, that was certainly interesting. Let's go look at this. So the data, so... huh. I'm wondering if the noise is mixed in with the DPCM channel. Just the one sample, but the engine is built for more. That's workable. I mean, sure, of course, with modifications, it could be built for more. You know what? Hang on a sec here. I want to look at something in the browser. Sorry, the browser's not actually going to show up on stream here, but I'll look up just some notes about the DPCM. Because when you write to the address, 8 times 64. So I guess the sample, okay, so sorry. So looking at the, actually no, put this over here. So it's FC and then FC times 64, comes out to be FF00. So that would mean, yeah, these 64 bytes are the sample. Alright, actually, make a note of that right now. The lone EPCM sample. So, I mean, these look like they might be possible. Yeah. Interesting. Alright, I think, yeah, that's gonna do it then for tonight. So, switch views here. Alright, so anyway, yeah, that was fun. Definitely enjoyed talking with you guys. So, yeah, we'll call it here, and let's, AA is alternating bits, so that's plausible as a silent lead-in. Yeah, could be. Could be. Let's see here. Alright, let's, yeah, we'll call it here. Yeah, 3 hours. That was a lot longer than I thought it was going to be. No problem. But anyway, yeah, I enjoyed doing this. Yeah, we'll definitely do some more code analysis then. Not sure when I'm going to do it. I probably will be decoding more of this off stream, of course. Maybe next time I'll have enough figured out so that we can actually edit the music and maybe even play a little custom song. Who knows? So let me do a little end card here and we will find someone to raid. Let's see here. Where's my controls?